All right, welcome back to episode 4 of the Passivhaus podcast. Great to be back with you again. How are you? Zach?
I'm well. Seattle is smoky, so that's a drag.
Yeah.
But we're soldiering on and hoping that the rain will come.
Yeah, and I'm Matthew, I should say, down here in Auckland, New Zealand. We're getting into spring right now, so starting to warm up, but we're getting a bit of rain, and fortunately no fires. But rain's good here too, because we did have a bit of a drought early on this year. Now, you had an interview recently with Sydney, who's our intern and editor as well. So who did you chat with, Zach? Do you want to give us a bit of an introduction?
Yeah, absolutely. So Sydney is friends with a couple of luminaries from the Passivhaus and building science world in New York City. Chris Benedict, who's a pioneering architect of Passivhaus projects there, and Henry Gifford, who is a building science practitioner and thinker and author of the book Buildings Don't Lie. And so we had a chance to hear stories from them about how they met and how they've collaborated, and really I think a pretty unique journey toward Passivhaus that was really fun to hear.
Well, let's get straight into it. So here's the interview with Zach and Sydney talking with Henry Gifford and Chris Benedict.
Begin a little bit of how you guys first met and then how you began working together in the same office.
I was in my second year of starting my office, and I had ambitions to do green and environmentally sound building, but there was not anything really around except a lot of architects talking about sustainable materials to use or recycled materials. So I was looking at those things. And I got an invitation to a conference put on by an organization called NYC. And it was like 3 days until the conference. I went to the conference because they had all kinds of promises for how to learn how to do environmentally sound work. And I spent a lot of the conference, ironically now, skirting every bit of building science, not attending any of the building science classes, not really even understanding what building science was or why that was important in any way. But the last day of the conference, there was a special breakout session on heating systems, and I decided to attend that. I was the only person in the room. Henry came, sat down next to me. I had a very shaved head, and my hair was about 1/8 of an inch long with bangs. And we started talking to each other, and you figured out we were both from New York. And I have to say, Henry was very negative, and I was like, I don't even want to talk to this guy. And then during the session, he asked the teacher a question, and the teacher didn't answer the question. So Henry raised his hand and asked it again. And I'm thinking, wow, this guy is like really a psycho. And we figured out we were both going to be on the same train leaving Boston back to New York. And so when the session was over, I ran out of there with my bag, ran over to the train station, and went all the way down to the end of the platform. So I absolutely would not be anywhere near him on the train. And then as I'm sitting there waiting for the doors to open, who comes walking down but Henry? And then on the way back from Boston, we ended up talking about my experiences as a beginner architect. And I asked him if he would come and look at some of the drawings I was doing.
Chris said that she just opened her office and she's planning to make all her buildings. She designs energy efficient and good and healthy for the occupants. And I asked how you plan to make them energy efficient. And she said, well, extra insulation and 2 panes of glass in each window. She's saying the same window would have two panes of glass in the one window. This was a while ago now. And I said, those things will not save any energy. She was shocked. She says, why not? I said, well, the people who live there in those apartments will simply open the windows further during the winter. And she says, in my buildings I design. I said, yeah, you live in New York, yeah. You open the windows in the winter, yeah. So the people in your buildings are going to open the windows in the winter. The only difference with the insulation and the double pane windows is they'll open them further. And she says, well, that's terrible. What do I do? I said, you have to have a thermostat in every room. Then you can stop the overheating. You can stop overheating the whole building to merely adequately heat the coldest room in the building. And then the insulation in the double pane will actually save energy. Mm. And she asked about how to get a heating system to have a thermostat in every room. That was a little bit advanced at the time. Sad to say it's a little bit advanced now, but that was what foot we got off on, the way I remember it.
Henry came to my office and he looked at my drawings and he said, "You're part of the problem." And he started taking me around to buildings in New York and showing me boiler rooms and boilers. And it was like a huge thing for me to realize, wow, number one, being environmentally sound has so much to do with energy. Like almost everything it's all about energy. And that wasn't even a topic being discussed in the green and environmental world. This was in 1996. So not only was it all about energy, but where are we using all the energy? Well, that would be down in the boiler room. And a boiler room was a place where architects, when the building was under construction, you would open the door, you'd look in, you'd see a lot of pipe, you'd see some guys, you'd see a boiler perhaps, and you'd just kind of look in and walk away because who knew how to even monitor that kind of stuff. So Henry started showing me, even in jobs where I had worked for offices that had designed those jobs, he had gone in and ripped the thing apart and remade it. And it was just a huge revelation to me that it was really, a lot of this stuff lived in the world of mechanical systems, of which I knew really nothing about until he started showing me. And, one of his first questions to me was, do you know how to do a heat load calculation? And I was like, a heat load calculation? And then I got myself a manual J, figured out what it was, figured out how to do it, figured out how to do it for a multifamily because it was developed for single family homes. And then a lot of the work moving forward for us was taking, his knowledge, the knowledge of some other fantastic building science people, a lot of the knowledge about single family homes, and then making that translation because we knew multifamily buildings, we knew apartment buildings, and we took that and kind of adopted it to the nature of a apartment building.
So when you, Chris, were working on sustainable design, when did you first hear, you can answer first and then Henry, when did you both hear about Passivhaus and that concept? Was that around the same time or?
No. Henry and I worked together for almost 10 years making energy efficient buildings before I heard about Passivhaus. Mm. And the thing was, we started playing a game, and the game was, we know that we can make buildings so much better just with code minimum. If you follow the codes and you do things correctly and you add the building science pieces to it, you can make way more efficient buildings. And those were the first buildings that we did. We played the game. All right, we're going to do code minimum. We're not going to increase the construction costs, and we're going to see where we come out. Where we came out was, between 15 and 25% of the energy use of a typical building by being really smart and responsible about what we were doing. And so that's where we were. And we would show our energy bills, and it really put us on the map. And we had a lot of credibility in a lot of different sectors, in weatherization, in building science, in multifamily building organizations. And so we were invited to talk about this everywhere. And it really wasn't until about 10 years later I learned about this thing called Passivhaus, where they didn't even have boilers. And I thought, how could this possibly be? I asked Henry, because Henry is a big boiler guy, you know, would it be okay if we make some buildings without boilers? And our buildings still do have boilers because, you know, we think that that is the most reasonable way to meet some of the loads, particularly domestic hot water these days. But Passivhaus was really attractive because it had all the things that we knew and had seen proven out, but it was organized in a different way. And the game with Passivhaus was an energy goal versus what our game had been, which was meet the building code and get the best building you can. So it kind of reoriented everything, but it was a lot of the same things.
For many years, I went to the plumbing and heating trade show in Germany. It's every 2 years-ish trade show. It's the biggest one in the world. I went to the one in China once too. And it was like pilgrimage to Mecca for me back in the day, seeing sealed combustion boilers before we had them here in the United States. The first time that Chris and I did some houses in Brooklyn, 2 and 3 and 4 family, with sealed combustion boilers, direct vent, chimney out the wall, the utility company red tagged the buildings. They said, well, you can't have a boiler with no chimney. That's illegal. The gas company had never heard of it. And we had to fight to convince them that this was a real way of doing things. And then they red tagged the house for having no thermostat. There was a thermostat in every room, but down on the heater, they didn't see a thermostat on the wall, so they figured there was no thermostat. So this stuff was really early here, but I got to see in Europe the way they do things and the size of boilers they have and the quality of design. The workmanship's a little better, but it was basically their thinking is so much ahead of us on the energy. I mean, we're catching up, but their mainstream, their low level, their terrible work is way ahead of what we're doing now in the best buildings. Maybe not the very best, but it's such a distance ahead of us. It was a big inspiration. And we see it, it's normal. The people who don't speak the native language, the immigrants from wherever they come to, whatever country, they don't grow up there. They're doing it, so we can do it.
Yeah. Is there anything else you'd like to add, Chris, to the last statement?
I would just say that it was, you know, in the early days, it was an incredible time of invention for me and Henry also. And we, you know, we would just run after anyone who we thought had any information about anything and just call them and talk their ears off, trying to just figure out, because, you know, we understood that something had to happen with the ventilation, and we knew there was, you know, there was exhaust only, and there was supply only, and then there was balanced ventilation. But, you know, how do you do it? And how do you compartmentalize an apartment building and have a ventilation system? Because in New York City, all the apartments are connected together with ventilation systems. You know, so we were just like in a continuous stream of invention, checking the code, getting permission to do X, Y, and Z because it was different, getting hung up on an inspection, having Con Ed tell us, oh no, we don't want to supply that amount of gas, that little amount of gas, that'll never heat the house. You know, all kinds of complaints of tenants saying, oh, you know, every time I turn my stove on, the heat turns off. There's something wrong with the heat. You know, when that was exactly the point, you know, that we're getting the heat from the cooking. You know, it was just a fabulous time. And I'm just really thrilled that I was able to get in at the very front of it and just kind of like be there, kind of plowing through every issue, because it was kind of, you know, an extremely exciting time.
We did dozens of houses in Brooklyn where we gave the homeowners our home numbers before cell phones, and then we gave them our cell phone numbers because we felt a strong need to defend our work against the world. We knew that people were going to come into these homes and tell these homeowners that that boiler is too small for that building and that heater is too small for that room. And invariably, some of these people would be people who worked in plumbing or heating or construction somewhere. Invariably well-meaning, we assumed, but scare these people. And then the first time there's a little problem, some people could come and start changing things and make a big problem. So we figured 2 winters and they would be safe. If somebody came after 2 winters and told them the boiler's not big enough, they'd get followed out their doorway with colorful language. But in the beginning, no, we had some interesting situations, but like Chris said, she had to sometimes sign her life away. The utility company wanted Chris to promise in writing that she would pay to dig the street up to put in what they considered a adequately sized gas service to go heat that building because they were sure it was too small.
Mm.
You know, another thing that we saw was that we were able to offer people a completely different kind of life inside of their apartments, because the typical New York City apartment building is overheated, very stuffy. Henry really, turned me onto this concept that the water is overheated, domestic hot water, and it's making faucets leak and bathrooms are dripping and there's mold growing in there and the ventilation is horrible. And there's like all these snowballing issues that create health problems and comfort problems in the buildings. And what we brought to buildings was fresh air, a temperature that was regulated, warmth because of the windows being good windows. And, it was a totally different life for an apartment dweller that we could make for them with sometimes a lot of the same pieces and just different thinking or slightly different pieces. We always tried to keep everything like within the technologies that we knew were being practiced, but there might be some slight differences, but we never wanted to go like too far in one step, as we were doing the work. So a lot of the stuff we spec'd, there were thermostatic radiator valves and they were European, but they're offered in the United States. We tried to use pumps that you could buy at the Home Depot, just keep everything like low tech. What happened as we were pioneering this way, the green movement started to come in and were then offered lots of bells and whistles and all kinds of technologies, while ours was extremely simple, but there was nothing to sell. And so, I think we ended up struggling a lot against that. Now, the nice thing with Passivhaus was, it had a name, it had a European history, so we could kind of surf on all of that, and all of a sudden what we were doing was a thing instead of me and Henry trying to make the best buildings we can, and so that was good to get that kind of consolidation under some kind of branding. And as you know, it really worked.
One of the boundaries that Chris and I have always stayed within is zero extra cost. We did what were the first energy efficient houses in New York. Some of the people in government agencies involved were in full favor, some were not, and nobody wanted to be the one to say no, but nobody was going to give us any money, and we didn't see any need for any money. We put more insulation and then took away a lot of expensive heating equipment. And the cost was a wash, and we still do it that way. Soon people started offering money, and it was clear right away that the money came with strings, and people were going to control us if we took their money, and they were going to control the story, and the story was going to be that this is not worth doing. this stuff sounds great, but it's not worth doing, because unless you can force all of your neighbors to chip in for your social statement, you can't do it. And that's not what we believe. We believe that every building should be done very energy efficient. We're friends with Gary Nelson, who had a vision that blower doors should move from being a research tool to a contractor's tool, that buildings should be airtight and not just, measured once in a while at some university. So he started making them. Minneapolis Blower Door he makes, the Energy Conservatory is his company over there in Minneapolis. And his wife, I think, works at the university, and they asked him about advice to build one energy efficient building. And he says, well, what's the point of having one really good building and 50 terrible ones? Why not do 51 great buildings? And the story that this costs more and you need a grant is the story that keeps the 51 buildings from being done well. And we think every building should be done great. Here in New York City, the city government periodically says that they're looking for the prototype apartment building of the future. How should things be done going forward, and how can we figure out how to afford it? Well, we've got addresses, we've got keys, we have Super's phone numbers. We can show you lots of these buildings, and they've been there for years, performing very well, well under 1/4 of the normal energy use of an apartment building. That's comparing Con Edison bills to Con Edison bills. That's not modeled energy. But they don't cost extra, so it's a big problem with the marketing. It doesn't have spin, there's nothing to sell. But it's harder to do. It's really hard to do what we do, and you have to learn a lot and you have to push a lot. But like Chris said, when it has a name and a spin and Passivhaus and the European identity, it makes it a lot easier to sell.
Yeah, I don't think we would have gone down the Passivhaus route if we didn't see a way to bring it in for the same cost as typical construction, because that was our brand. And so, we kind of figured out how to get a good enclosure, by doing exterior insulation. So our first job, 803 Knickerbocker, was all eaves and done, in a very sculptural way. And we got a lot of insulation on the outside of that building. And we brought it in for the same cost as typical construction. And so I think that was one of the tantalizing things was, as Henry said, people were saying, well, why make one really fantastic energy efficient building when we could make 50 that are more energy efficient? And what we saw was, no, you can make 50 that are fantastically energy efficient.
One of the things I'm struck by is this kind of spirit of curiosity that you're both describing. So, Henry with the trade shows in Germany and China and seeking out information there. And Chris, your description of seeking out info wherever you can, like this real hunger for learning and practice. So I think that's a good segue to, Henry, your book, Buildings Don't Lie, because that's an example of transmitting probably what you've been learning. Could you talk a little bit about that book and some of what your motivation was to write it and some of the high level pieces around that? Because it's a real touchstone, I know, for practitioners in this space.
My biggest motivation for writing Buildings Don't Lie is that this big knowledge vacuum. People are learning now details, how to make a building airtight, how to make a building energy efficient. But there's no good source for the underlying knowledge, the science of why certain details work. And nobody's brain is big enough to memorize all the things they would need to know for all the situations they could come, all the different types of buildings, all the climates, all the situations, all the different materials that are there now and will be. So the only solution is to understand the underlying. And I found the instruction books for the instruments with huge mistakes that they didn't correct. They knew about them and never correct. I'm like, well, how many people actually measure anything in this country? These people sell the best instrument for measuring electricity, and the instructions are all wrong. And I'm not sure a few of the things are really right about the whole thing at all. Still don't know. And so what's the state of this art? Measuring? But I got 2-3 years of really satisfying curiosity. It was really great. I miss it now, though. I really miss looking at a building, wondering how something works. And I miss the feeling of coming from a conference with the phone number of somebody who can really straighten me out on something. Like, I could really find out from this person, and now I don't have that in my life anymore, so it's sad. But I wrote Buildings Don't Lie so that people, anybody who wants, can have a resource. They can find out the underlying science. So first chapter is heat, the basic science, nothing about buildings, just heat. What is heat and how does it work and how does it go from one place to another? Then chapter 2 is heat flow through buildings. Then air, basic science, then air in buildings, then water. Why does a water molecule behave the way it does? Why do drops behave strange compared to water as a gas? All that weird stuff about water, surface tension, all that stuff. Then there's a chapter on water in buildings, and that's the heat, air, water. Changing the flow of any one of those things changes the flow of the other two, so they're very interrelated. So that's the basics, and that's the first 256 pages, I think, just to cover the basics, And I got into other things, but very much of the book I split between the basic science unrelated to buildings pretty much, and then the science that's related to buildings. You could call it the blue collar and the white collar look at it. It's two very powerful ways of looking at things. And if you have both, you really stand head and shoulders above most people who have a vision of one side of it or the other, but not both. So this book gives both sides to people. 11 years, really hard work and not doing as much paid work as I would have, and a lot of photo taking and running around. But I had a lot of fun with the book.
Yeah, what a project. And where can listeners find it?
We have a website, buildingsdon'tlie.com, or you can buy it on Amazon, Buildings Don't Lie by Henry Gifford. The full title is Buildings Don't Lie, Better Buildings by Understanding Basic Building Science. So, Chris, you're one of the pioneers of Passivhaus architecture in New York and in the country. And I guess what I'm really curious about for you now is, what are the design problems around Passivhaus that are most interesting to you? Like what's really engaging your brain around this stuff today?
Well, we have a big job right now trying to bring Passivhaus to existing construction with tenants in place. And it really has taken everything that we have to get this to work. We had a lot of experience in substantial gut rehab of existing structures, some experience in tenants in place work. Then we have the new construction, exterior insulation. So we kind of took all those pieces and put it together into a scheme where we are renovating existing buildings with tenants in place by doing a bulk of the work from the outside of the building so that we don't have to go into tenants' apartments. And so that job is underway right now, and it has been incredibly interesting. We've always tried to, go to the next step. After we get some mastery of something, we move to the next one. And so now we're getting this one under our belt. And so these buildings are at about 50% complete right now. Their roofs are basically, I guess you would call it the mechanical room of the building. So up on the roofs are ERVs and ductless split systems, and all of their ducts and refrigerant lines and everything come down the sides of the outside of the building and then poke into the apartments, so that at some point when everything's all set up, a contractor goes in and in a few days puts the head on the ductless split, puts the grills and the constant airflow regulators on the ERVs. The windows are installed outboard of the existing windows, the frames of them, and then they can pull the inside window out and install the sash. And so everything has been kind of figured out to have the least amount of tenant impact. And we've learned a lot. Some of the things like, just installing the frame of the window outside so that people can maintain their double hung windows while they need to access a fire escape or have an air conditioner in the window until we're ready to come into their apartment and pull out the entire window. Like a lot of the stuff we're just kind of like learning on the fly, problem solving, inventing, so once again, it's like super great to work on.
Yeah, I mean, that's really where it's such the cutting edge right now around thinking about energy in buildings too, is figuring out how to make retrofits work. I know that there are lots of, NYSERDA and Rocky Mountain Institute and all sorts of institutions who are working on it. And I'm sure that there are lots of lessons learned that you guys are kind of going through and discovering that will be useful to this larger effort.
I mean, what I love about being an architect is like it's, between the legal, the codes, the materials, the putting it together, the art, you've got all of that you have to like wrap into a solution and make work.
Absolutely. Henry, did you have something you were going to add?
Well, unlike those research people, we're not working on it. We're doing it.
Right. Right. Yeah. Absolutely. Awesome. Well, we've thank you so much for your time and insights and story and inspiration here. We've taken up a good chunk of your time. So I don't want to impose on you anymore, but is there anything else you'd like to add?
Well, I have something. I just want to say, there's no waiting. We can't wait for the grant or the government to do these things that need to get done. Our work has always been and always will be, self-motivated because we're interested and we're human beings on a planet that needs our work. So, there's really no reason to not at any point be jumping into this and to be taking, whatever role you are in the world, if you're an architect, a contractor, or in any other field, figuring out what it is, the road that you can take to keep our planet intact. There's no waiting. The time is now.
A lot of my motivation has always had to do with world peace. I think a good case can be made that all the wars in the 20th century had a lot to do with oil and access to oil. And somebody in Africa kills 1 million people and it hardly makes the newspaper, but somebody in the Middle East throws a rock at somebody and the army shows up. Well, why is the army always hanging around the Middle East? Well, there's oil there. So I think if we way reduce the amount of energy we use, we can way reduce the incidence of war.
Alrighty, and that was Henry Gifford and Chris Benedict. And as you said at the outset, luminaries in their field, pretty inspirational stuff. A couple of things that I took away from that interview, Zach. Firstly, I should just quickly mention Manuel J. That'll be very familiar with technical people in North America, but outside of North America, are you able to describe what Manuel J is?
Here, let me look it up here.
It's essentially the part of the code that deals with heating and ventilation. So
right.
Setting
calcs for sizing equipment and the system. Yeah. A
couple. I mean, there are some interesting points about that. There's the fact that, and this was fundamental to that interview, I think, is that it's such an ingrained part of a building. The assumption in North America, at least, and in Europe, a building must have a boiler. Yeah, it's part of what you do. It's just like you create space for a boiler room. You create, you expect all this infrastructure for mechanical services, and that's what Chris talked about, is that that was the way that she did things. And then meeting Henry, this is way before they even came across Passive House. The conversation seemed more about how to make that more, as efficient as possible, how to reduce the size of the boiler, how to tweak it. And she talked about adding building science to a minimum code building and getting some pretty impressive results, 15 to 25% less energy use, just by applying a bit of science to a standard building construction. So that, I think, really shows what can be done if you think about the way things have always been done and start to question that.
Absolutely. You were talking about a car metaphor. Wait, you should share that before.
Yeah, so because my dad motor mechanic, and he used to love tinkering with things, and the progression of the internal combustion engine over the last 100 years has been quite phenomenal. Just the amount of power and efficiency we get from the same amount of fuel now compared to 100 years ago. And we've done that by just tweaking the science and improving incrementally the performance of an internal combustion engine. Now we're getting to a stage where we're adding electric motors to that, and we've sort of got the hybrid models. And I think of that as a building that is a high performance, but in the same way that with electric vehicles people have range anxiety, perhaps in buildings we have boiler anxiety or mechanical systems anxiety, where people aren't necessarily prepared to take the leap to just exclude those systems completely. And that's sort of like the hybrid car model. But we have on the horizon, and people have them right now, full electric vehicles, and a lot of people have made that leap. And the analogy there is, I think, the Passive House, where Chris came across this idea of, and she mentioned it in the interviews, like, what do you mean I can have a building with no boiler? And we can do that. We know how to do it. We have the technology to do it. But the challenge, I think, is the psychology and getting people to believe, the designer and the architect, the consultant, that everything's going to be okay without this thing that has always been there. And we have parts of the code that basically specify how big it has to be.
Yeah, I think another interesting piece of this analogy is that there's this. It is also the complexity versus simplicity. And that I think probably a lot of listeners have seen the photo of an internal combustion engine vehicles, all the parts spread out on the ground, and there are I think a couple thousand different parts, moving parts.
Amazingly complex, yeah.
And then if you do the same with electric vehicles, there are very few. It's a very, very, very simple, like, I think maybe, it's like between 15 and 20 moving parts or something ridiculously different.
I drove a Nissan Leaf for a little while, and I showed my dad, who was a motor mechanic, and under the hood of a Nissan Leaf, it's really, really boring. There's hardly anything there.
Right, exactly. And so the same is true for this I think paradigm shift from the mechanical system intensive 20th century buildings to the new envelope focused, very much more simplified high performance buildings that we're creating now through Passive House design. And that's a theme that Todd Rothstein, actually from Avesta Housing, talked about in this week's Global Passive House Happy Hour, where he was discussing the fact that they're discovering that as an affordable housing provider, they can't afford the new mechanical systems that they can't afford the next sort of incremental improvement in mechanical systems within the old paradigm. And then it's really the investment, switching to an investment in envelope first that is allowing them to deliver on affordability and performance and comfort for their residents. So it's
so interesting.
Yeah. So I think a lot of interesting parallels. It's all just one of many, I think, parallels actually between the transition that we're seeing in the passive house world and the broader clean energy transition.
Yeah.
It's
Yeah.
pretty fascinating stuff.
And good segue to the Passive House Accelerator, Zach. You mentioned the Happy Hour, another great one this week, and more of those coming up. Do you know who's coming up next week in the Accelerator?
The next one's going to be really great. It's Maureen Sanchez. She's a powerhouse of passive house design and engineering, who's based at RDH Building Sciences office in Toronto. Awesome. And she's going to present about the Passive House Student Center, dormitory and student center at the University of Toronto, Scarborough, at the next happy hour. And we also, I rather than going into a lot of detail about all this coming down the pike, I'll touch on it.
There's almost too much. There's almost too many.
Exactly. I will share a link to our weekly Passive House Roundup that has links to key things. PHIUS has announced a series of what they're calling Hootenannies events that are going to be deep dives for policymakers and builders and others that are going to happen in October. So that's something to look out for and save the date for. They also have some trainings coming up. We have the International Passive House, the PHI International Conference starting on September 20th, and an associated Passive House Fundamentals course related to that. They're also, PHI is also having its open International Passive House Open Days, November 6th through 8th. And that's going to be largely virtual. So if you have a project that you'd like to share, you can create a short video and submit that and have people around the world come tour your project virtually, and then just lots of other events going on. So we have that all in this little roundup article that I'll share in the show notes. And of course, we have the South Pacific Conference coming up. You should
registration's open. Yeah. Registration's open for that now. That's later on in October, 12th to 16th of October. So registration's open, and I and some colleagues are busy preparing our presentations for that right now.
That's fantastic. I'm looking forward to taking in some of that. It's pretty fun to be able to do that from Seattle.
That's right. Well, that's the benefit of having all these online events now.
Indeed.
And also, don't forget to head on over to buildingsdon'tlie.com. Henry did mention that during the interview. I'm going to be checking out that book and requesting that for Christmas, I think. It looks like a fantastic read for anyone who's interested in building science. And I'm guessing that if you're listening to this podcast, you probably should be very interested in building science.
I think well, just one last thing on the book is that he takes a very visual and non spreadsheet based approach to communicating these concepts. It's I think very kind of accessible, but also deep. So so
it might be a good one to give to someone who isn't as geeky as we are.
Yeah, exactly. Or it's actually probably perfect for me. Not to say I'm not a geek, but
awesome. Who do we need to thank this week?
Yes, absolutely. Well, as you know, our work at Passive House Accelerator is made possible by the sponsorship of like-minded organizations. So these are companies that share our mission to accelerate the decarbonization of buildings, and so we really encourage you to check them out. Our founding sponsors are Baxt Ingui Architects, Mitsubishi Electric, RDH Building Science, Stowe Corp, and Zola Windows. And our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. So thank you to our sponsors.
Thank you to them. And once again, thank you to Sydney for putting these podcasts together. She's doing fantastic work. She is an intern and helping out at the Passive House Academy. Sorry, not the Passive House Academy, Passive House Accelerator. And also was the interviewer this week. So look forward to getting her voice back on the podcast at some stage in the future.
Indeed.
And we do have a bunch of great interviews lined up. So please, if you haven't already, make sure you subscribe and tell others about the podcast as well. You can also head on over to Apple and leave us a rating and a review over there. That really does help get the podcast out there, because if Apple chooses to promote the podcast, then it puts it up and makes it more easy to be found. And that's the idea, is to get the message out there to more people, so that we can have more passive houses and more better buildings around the world. Thank you very much, Zach. I look forward to chatting again next week.
Thank you, Matthew.